Hello everyone, my name is Anushri, third year BE in Information Science and Engineering student at Sri Venkateshwara College of Engineering, Bengaluru. Today's topic of my presentation is structural testing, the overview of structural testing and the statement testing from the subject software testing holding the code 21 IS 63. So first of all, what is structural testing? Structural testing is a type of a software testing that uses the internal design of the software for testing, or in other words, the software testing which is performed by the team which knows the development phase of the software is known as structural testing. So, the structural testing is nothing but a process in which the development team conducts the software testing, which knows the internal structure of the code of the software. So, in order to test the internal design of the software, the structural testing can take place. Structural testing is related to internal design and the implementation of the software, i.e., it involves the development team members in the testing team. It tests the different aspects of the software according to its types. Structural testing is just the opposite of the behavioral testing. As I already said, structural testing is nothing but testing the internal design and the structure, the implementation of the software, wherein which the testing team involves the developing team, meaning that the developing team is the one which developed the software. So the testing team is nothing but the developing team which developed the software. So it tests the different aspects of the software according to its types, like different types of the structural testing. And it's just structural testing is nothing but it's just the opposite of the behavioral testing. So in the structural testing, it can be mainly broadly divided into four types. First one is control flow testing, and the other is data flow testing, and other is slice based testing and the mutation testing. So first of all, what is control flow testing? Control flow testing is a type of structural testing that uses the program's control flow as a model. So in the control flow testing, we use the control flow of the program. So the entire code, design and the structure of the software have to be known for this type of testing. In the structural testing, as I already said, the development team will be involved in the testing team. So it must know to perform the control flow testing, the team must know the entire code, design and the structure of the software, how it is designed and how the control and the flow is being controlled in the program. So to of the software have to be known for this type of testing. Often this type of testing is used by the developers to test their own code and implementation. Whenever the developers complete this SDLC, that is software development life cycle, they come to the stage where they need to test their code. So the developers can use the control flow testing in order to test their software. So this method is used to test the logic of the code so that the required result can be obtained. So in the control flow testing, we can or if you wanted to test the logic of the code, we can test the logic of the code so that the required result can be obtained after the testing. So in the data flow testing, it uses the control flow graph to explore the unreasonable things that can happen to the data. So in the data flow testing, we encounter this type of a testing whenever we use the control flow graph. The control flow graph is nothing but we have this opportunity to explore the unreasonable things that happen with the data whenever the data is being defined, whenever the data is being the wherever where and all the data is being used after the definition. The detection of the data flow anomalies are based on the association between the values and the variables. The anomalies which occur in the data are mainly basically because of the association between the data variables and the values, and it is being initialized usage of the variables. Initialized variables are used once whenever they have been defined. They must be used once whenever they have been defined. So whenever we do not want any type of a variable, we shouldn't define anything. And if we define any variable, we need to use at least once in our program in order to effectively use the data flow. So next we have the slice-based testing. In the slice-based testing, it was originally proposed by the Weiser and Gallagher for the software maintenance. It is useful for software debugging, software maintenance, and program understanding and quantification of the functional cohesion. So whenever we test the software, we can test the software in the form of pieces of the code or a slices of the code. The whole software is then divided into a complete slices, and better when we divide something into a better slices, we can understand the software better, we can understand the maintenance of the software, and we have this strong fundamentals of programming understanding and the quantification of the functional cohesion. So it divides the program into different slides and tests the slide which can majorly affect the entire software. Whenever we divide the software into the slices, and then we perform the tests on those slices, and then we again integrate all those slices, and majorly we come up with the output for the entire software is nothing but a slice based testing. And mutation testing, mutation is nothing but change. Mutation testing is a type of software testing that is performed to design the new software tests and also evaluate the quality of already existing software tests. Mutation testing is related to modification of a program in a small ways. It focuses to help the tester to effective tests or to perform the effective test or locate the weaknesses in the test data using the program. As I already said, mutation is nothing but mutation testing is generally related to the modification of a program in a small ways. Whenever we want to change anything, whenever we want to change the data type of a variable or the assignment where we are assigning a value, the mutation testing is nothing but whenever we have the mutations in the project, or whenever we want to change something in a project in a small ways, then mutation testing comes to the picture. So advantages of the structural testing. It provides the thorough testing of the software. It helps in finding out the defects at the early stage, and it helps in elimination of the dead code. It is not time consuming as it is mostly automated. So the structural testing advantages is nothing but it helps in thorough testing of the software, and it eliminates the dead code wherever it is present in the software, and then it detects the defects at the early stage, and it is not at all a consuming process, time consuming process, as it is mostly automated. And disadvantages of structural testing is nothing but it requires the knowledge of the code to perform the test. It requires the training in the tool for the testing, and sometimes it may be expensive. So whenever we want to test the software using the structural testing, we need to have this programming knowledge and we need to know the how the code is implemented in the software. So the people who don't know how knowledge of the do not have the knowledge of the programming or the how the code is implemented, they cannot perform this type of a test, and that is one of the major disadvantage. And the other disadvantage is nothing but it requires the training in the tool used for testing. Whenever we use the tool which is helpful in performing this type of structural testing, we need the training for testing the tool. We need the training to how to use the tool for the testing. That is also a time consuming process, and sometimes it can be expensive. Structural testing tools. Structural testing tools are JBehave, Cucumber, JUnit, and CFix. Statement testing. The statement testing is nothing but a statement coverage technique. It is used to design the test cases for the white box testing, which involves the execution of all the statements of the source code at least once. The statement testing is nothing but it is a type of white box testing. A white box testing is nothing but whenever we know the implementation of the code, or we have the programming knowledge of how the code is implemented without blindly testing, is nothing but a white box testing, and it involves the execution of all the statements of the source code at least once. Whenever we have the statement in the code, and the code whenever the statements are executed at least once, it's the type of a statement testing. It ensures that all the statements of the source code are executed at least once. It covers all the paths, lines, and the statements of the source code, and it is also used to design the test box cases, wherein it will find out the total number of executed statements out of the total number of present in the code. Whenever we have the piece of a code or a function in the function of the code, the statement testing is nothing nothing but it finds out the what amount of statements or a total number of executed statements out of the total number of statements which are actually present in the program. So the statement coverage is nothing but number of executed statements divided by the number of statements which are actually present in the source code into 100. So in example 1, we have this piece of a pseudocode or a type of algorithm wherein which we have the read A, read B, and if A is greater than B, print A is greater than B, else B is greater than A, and if. So total number of statement here is 1, 2, 3, 4, 5, 6, 7. So case 1. Consider we give the input A is equal to 7 and B is equals to 3. If A is 7 and B is 3, obviously A is greater. So first it will read A, the statement gets executed, then read B, executed. If A is greater than B, A is greater than B, 7 is greater than 3, then print A is greater than B, it will get executed, then else part will not get executed, and end if will execute it. So totally we have read A, read B, if A is greater than B, print A is greater than B, end if. So 5 statements are executed. So the total number of statements executed here are 5, and the total number of statements which are actually present are 7. Statement coverage is nothing but 5 divided by 7 into 100, which is 71%. Case 2. So let us consider the counter case, that is if A is equals to 4 and B is equals to 8, read A and read B will obviously get executed, and if A is equals to A is greater than B will execute, because we need to check if A is greater than B. We can't jump directly into else part. So if A is greater than B, yes, it will execute. 3 statements are executed till now, and then it will jump to the else part because A is not greater than B, B is greater than A. So else part, and then else is a fourth statement to get executed, and print B is greater than A. So that statement will get executed, and end if will get executed. So the total number of statements executed are 6, except the print A is greater than B. All other statements are executed. So the total number of statements executed are 6. The total statements which are present in the program are 7. Statement coverage is 6 divided by 7 into 100, which is 85.20%. We have the other example, that is printing the A and B, like we are inputting the A and B from the user, and we are saying if the sum is positive or if the sum is negative. So here total number of statements are 8, that is print int A comma int B, and the curly braces and the function which is written within it. So if A is equals to 4 and B is equals to 8, the sum will be obviously 12. So total number of statements which will be executed will be print int A comma int B will get executed, the curly braces will get executed, int sum is equals to A plus B, which is 8 plus 4 will executed, that is 12. If sum is greater than 0, yes, it will get executed. Print result is positive, it will get executed. Else part will not get executed. Then we have this curly braces to get executed. So the total number of statements executed will be 6. Out of total number of statements which are actually present are 8. The statement coverage is 6 divided by 8 into 100, which is 75%. Then case 2. Case 2 we have if A is equals to 4, B is equals to minus 8, then the sum will be obviously in minus, that is negative, which is minus 4. So the else part will get executed. So the total number of statements which will be executed will be print int A comma int B, the function, and then the curly braces, and then int sum is equals to A plus B, that is 4 plus minus 8, which is minus 4. If sum is greater than B, it will check the if statement. So if will get executed, then the print doesn't get executed, that is result is not positive, then it will jump to the else statement, else will get executed, and then the curly braces. So total number of statements executed will be 7, except the print result is equals to positive, that is total number of statement executed is 7. Out of total number of statements which are present are 8. So statement coverage is nothing but 7 divided by 8 into 100, which is 87.50%. Statement testing covers the dead code, unused statements, unused branches, missing statements, and all. So why is statement coverage testing used? To check the quality of the code, to determine the flow of different parts of the program, check whether the source code expected to perform is valid or not, test the software's internal coding and infrastructure. So whenever we define any data structure or data type, we need to check whether it is getting used or not. If it is not getting used, then it is a dead code type of thing and we can delete that. So in order to do that, we can check the quality of the code by using the coverage testing, and we can also determine the flow of the different parts of the program by using the statement coverage testing. Drawback of a statement coverage testing are it cannot check the false condition, different input values to check all the conditions, more than one test case may be required to cover all the parts with a coverage of 100%. So these are some of the drawback of a statement coverage testing. It cannot check the false condition. It cannot, the different input values need to be given to check all of the conditions. So that's all for this video. Thank you.